We are on chain rule, whereby we shall be differentiating a function within a function. We shall introducing a letter u, basically to call the function that is inside to be able to assist us. So that's what we shall be doing. We introduce a u, then we differentiate the u, and then there's a formula that we shall be able to use. So basically what I'm saying is that we shall be able to introduce a u, then differentiate, to get du dx, du over dx. And basically the y now will change now because we are introducing a u basically to replace a function. So y will be in terms of what? U. Again, here we differentiate, we shall get dy all over du. So basically, if we go through the notes, basically, we want to say that now dy over dx, because we want dy over dx, will be given by dy all over du, and then times du all over dx. And you can be able to see if I cancel the du and the du, basically I'll end up with dy dx. So I'm introducing, basically we shall be differentiating in terms of u, and then the u shall be differentiating in terms of x. And the function, basically, like the example that I want to do, you'll be able to see it more clearly. But this is the formula if you want to do chain rule that you need to remember. That is the formula that you want, that dy will be given by that dy dx. This is the formula, very important, that dy dx will be given by dy du or du dx. Basically, you are just multiplying the two. The order doesn't matter. You can still multiply du dx times dy du. Let me do an example to demonstrate this. So let's say you are given y is equals to 2x plus 1 raised to power 3. So you see that function, there's a way you can still be able to differentiate it by expanding. By expanding 2x plus 1 raised to power 3 using what? Binomial expansion. You can be able to do that using binomial expansion, but it is a bit tedious to expand that one. Very tedious. So this is one of the application of chain rule. There's a function within a function. So the function is 2x plus 1, and then we have another function which is power 3. So we have the function 2x plus 1, then we have another function which is 2 power 3. So if you want to expand this one, you can able to expand on your own, multiply 2x plus 1, then multiply 2x plus 1, and then multiply by 2x plus 1 3 times, which is a bit tedious. So what I'll be able to do, the function in brackets mostly, I'll call it u, which is 2x plus 1. And then here my y will be now, you see now, I replace now the 2x plus 1 with the u, so I'll have u raised to power 3. It's just a matter of replacing 2x plus 3. Now from there on, this one on the left hand side, I have u, so I'll have du all over. On the right hand side, I have what here? X, well, it will be du over dx. We always start with the function on the left, then the function on the right, just like dy dx. Always start with the function on the left, then function on the right. So this one, when you differentiate using power rule, you'll end up with a 2. 2 plus 0, okay, for the sake of Nini, because x can be given as power 1, the power will come down, you reduce the power by 1, will remain with 2. So this one will end up with just 2. This other one, if I start with the function on the left is y, so I'll have dy. The function on the right is u, so I'll have du. Again, I differentiate this one, the power rule will work, the power will come down, you reduce the power by 1, that is 3 minus 1. So I'll end up with 3u squared. So the other task is just to multiply the 2 The order doesn't matter, so the final step is just multiply the two. So dy all over dx will be given by dy all over du times du all over dx. So I'll just multiply the two. So I'll have 3u squared, and then I multiply by 2. If you multiply this one, I'll get what? 6u squared. 3 times 2 is 6. From there on, remember I did not have a u. I introduced a u to help me. So I must be able to go back and replace back the value of u. So I go up and then I check my u. My u was 2x plus 1. So I need to replace back. But u is equals to 2x plus 1. So dy all over dx will be given by 6 and then 2x plus 1 squared. So that's how you do it. You're introducing a u for polynomials or algebraic functions with the function in bracket. You leave the power in terms of u, and then you differentiate, multiply the two, and then you replace back the value of u. You can be able to do another example. You do another example just to demonstrate that. So this one I'll have number 2. Y is equals to 4x minus 3 raised to power 4. So again, that function to do what? To expand using binomial function is a bit tedious. So what I'll do, I have the function 4x minus 3 within another function of the power. So it's a function within a function. So whatever is in brackets, I'll call it u. Let u be 4x minus 3. And then I will write now y in terms of u. So y will be given by u raised to power 4. So from there on, I differentiate. The function on the left is u, so I'll have bu. The function here on the right is x, I'll have dx over dx. To differentiate this one using power rule, any number can be given as power 1. So 4, the power will come down. You reduce the power by 1, 1 minus 1. Differentiate a constant, you will always get 0. So this one I'll end up with the just 4. The other one, this side dy, the function on the left is y, so I'll have dy. The function on the right is u, so I'll have du. If I differentiate this one, the power will come down, reduce the power by 1. I'll end up with 4. U raised to power 3. Sorry for that. So my work now, it was just multiple. Even if you don't remember the formula, I want to make your work easier now. If you don't remember the formula, what you just need to do is to multiply these two, the du dx and the what? And the dy du to get dy dx. So what I'll be doing, I'll just be multiplying. Let's say if you have forgotten the formula. So our main task is to multiply these two, the one that you have differentiated, only that. So let's multiply. So dy all over dx will be given by 4, and then 4 u raised to power 3. Then I'm getting 16 u raised to power 3. But remember, I did not have a u. I need to go back and replace back the value of u. So I go up again, but u was what? 4x minus 3. So I'll go back and replace, but always be replacing back. The u was to assist us. So u is equals to 4x minus 3. So it means that dy all over dx will be given by 16, 4x minus 3 raised to power 3. So remember, you must be able to put the brackets because of the power. And you can, I'll be able to demonstrate something later on. Number, you can be able to do number 3. Number 3. So y is equals to 1 minus, let's say, 5x raised to power half. So again, this one you cannot be able to expand power half. So we have a function 1 minus 5x. It is inside a square root. Basically, I have is the square root. So it is basically a function within a power of a half. So again, I'll introduce a u. So let u be whatever that is in the brackets. Then I will write y in terms of what? U raised to power half. Then I'll differentiate this one. The function on the left is u, so I'll have du. The function on the right here is x, so I'll have dx. So this one, differentiate a constant, you get 0. Any number can be given as power 1. So the power will come down. So 5, the power will come down. Reduce the power by 1, 1 minus 1. So I'll end up with what? Negative what? Negative 5. Here I'll get dy all over du. The function on the left is y. The function on the right is u. So I'll have dy over du. Again, the power will come down. You reduce the power by 1. So when you get a half minus 1, you get negative a half. Yes. And I'm getting a half, u negative a half. So after differentiating the two, we just need to multiply them. So I'm assuming that even you can't recall the formula. So what I need to do is to multiply these two. Just multiply those two. Let's see what I'll be able to get. So dy, remember we are looking for dy over dx. The u is assisting us, so negative 5 brackets multiplied by a half, u negative a half. Even I'm ending up with negative 5 over 2, u negative a half. But again, I need to replace back the value of u. I go back, but u was 1 minus 5x. So I need to replace back 1 minus 5x, but u was 1 minus 5x. So dy all over dx will be given by negative 5 over 2, and then 1 minus 5x raised to power negative a half. And I'm done. You can be able to see my answer is in terms of x. There's no u, so very important. Okay, look at this answer. Look at this answer. Look the answer that I have. You can be able to see the function that I had called 1 minus 5x. It is still remaining in the answer. This is what I had before. I want you to see something. This is what I was told to differentiate. You can be able to see 1 minus 5x raised to power half. In the final answer, I'm still having 1 minus 5x. Look at the answer. In the final answer, I still have it. It is here. 1 minus 5x is still appearing. So you can be able to see whatever you are calling u will be able to appear. Even in the previous example, whatever we had called u was still appearing. I do the example number 4. Y is equals to, let's say, 6x minus 5 raised to power 5 over 2. We see that one again. So again is a function within a function. I will call u. I will call the u. I'll be able to call the u. So u here will be whatever that is in brackets. I write y in terms of u. It will be u 5 over 2. So here the function is we have a u, so I'll have du. The function on the right is an x, so I'll have dx. If I check this one now quickly, we move a bit faster, you just get a 6. And here dy all over du. The power will come down, reduce the power by 1. What is 5 over 2 minus 1? So you're ending up with what? That is 5 over 2 minus 1, 5 minus 2. So you're ending up with 3 over 2. So now we just need to multiply these two, and then we replace back the value of this. So we need to multiply those two to get dy dx. So here dy dx now, dy dx will be given by 6, and then 5 over 2, u 3 over 2. I can be able to cancel this one and this one by 3. So I'll end up with 15 u 3 over 2. But but we go back to u. You must always go back to u. Our u was given by 6x minus 5. So the u will always remain in the final answer. If you want to know if you are doing the correct thing, so dy all over dx will be given by 15, 6x minus 5 all over 3 over 2. That's how you do it. That's how you do it. Just introduce a u, differentiate the two, and then you multiply. Final example now on this side now. I think that is number 5. Number 5. Number 5, we have y is equals to, let's say, 2 all over raised to power 2. That one there. So this one is a typical example of power rule, and I'll be able to demonstrate that one for you. So again, 2 is a constant, the one on the numerator is a constant. So we are concerned with the function in brackets. So that's what I'll concentrate with. So let u be 8x minus 6. And then now y will be given by whatever that is remaining. U raised u squared, u squared. So I differentiate here. Du all over dx will be given by 8. Someone to do this one for me, get for me dy over du. If you get that one, then I'm okay. Dy over du, let me mute. Denominator, I think I had said this one in the previous classes. So this one will be given, check this one out. I manipulate this one. When a positive power will go up, it shall become what? It shall have 2u negative 2. And the power has to come up. The power has to come up, so at least you can be able to differentiate. When a positive power will come up using laws of indices, it will become negative. So now I differentiate now. dy all over du now. So I have a 2. So the power will come down negative 2. And then I reduce the power by 1, negative 2 minus 1. What is negative 2 minus 1? So this one I'll be able to get negative 4u negative 3. So we say now I need to multiply this one and that one. And then I replace back the value of u. U is 8x minus 6. Master that one. So here dy all over dx will be given by 8. And then negative 4u negative 3. 8 times negative 4, negative 32, u raised to negative 3. But u was given by, you remember, 8x minus 6. So I replace back that value there because our u was assisting us to differentiate. So we need our final answer in terms of x, not u. Will be given by negative 32. 8x minus 6 raised to negative 3. And that is the final answer. So please, when you have a denominator, kindly take it up. Kindly take it up, and you'll be able at least to differentiate. Those are the basics that we learned on power rule. Those are the basics that we learned in power rule. Anyone with a question there? When you differentiate sign, what do you get? There's a table for that. Please don't cram it. You can be able to use it even during the exam. And by the exam will be online, so you can be able to use it. I don't have a problem. The problem is not using the table, but how to differentiate. Let me go to exponential. So on the table that I've given you for the exponential function, if y, master this one, y is equals to exponential x, master only for this class. When you differentiate dy all over dx, you'll get it what? You'll get it still exponential x. So when you differentiate an exponential function, you still get an exponential function. That is from the table. That is from the table. Differentiate an exponential function, you still get an exponential. So we do an example now. We're using chain rule to differentiate. Y is equals to exponential, let's say 3x. Someone to try to give me dy dx of that one. The mics are open. You can be able to use the mic. I just want, basically for exponential, you can be able to see we deal with the function that has the power. The function that has the power. The function that has the power. So this one is the one that we normally call our u. This one here. This one here. This one is the one that we call our u. So exponential, you go just to the power. You just go to the power. So you want to differentiate this one. I want to use chain rule. So I'll call let u be 3x. So I'll have here dy. Sorry, I'll have y now. I write y in terms of u. So I replace that one and be able to have now y will be given by exponentially. Now this one I differentiate here du all over dx. I'll get 3. The power will come down. That is power 1. 3 times 1 is still 3. Reduce the power by 1, you get x raised to power 0, which is the same as still 3. Now here I'll get dy all over. The function that is here is what? Du. So let's go back to what we had done here. When you differentiate exponential x, you get exponential x. So when you differentiate exponential u, what do you think you will be able to get? The hint is there. You can be able to get that. You're reading it from the table. So I'll still get exponential u. So differentiate exponential u, you'll still get exponential u. So the other task is for me just to multiply these two. What we are doing. So dy dx now. Remember I was looking for dy dx and I don't have it. Dy dx will be given by 3 and then exponential u. The same as 3 exponential u. But I go back. What is our u? Our u was 3x. So I need to replace back the value of u. Please don't forget about that. But u was 3x. So dy dx will be given by what? 3 exponential 3x. Exponential 3x. Let me give you one to try before I do it. This one number 2. Y is equals to exponential 4x. If you get this one, I know you are. So try this one. Give me the answer for that one. Let me go back. So I'll call my u the power. So u will be given by 4x, and then y will be given by exponential u. So here I'll get here du all over dx is 4. When you differentiate exponential function, you still get exponential function. Then I multiply these two. If I multiply those two, dy dx. If I multiply those two, I'll get 4 exponentially. But what? Our u was 4x, remember? So I'll get 4 exponential 4x. I'll be able to give you now a hint of what is happening now, because for later ones, you can be able to do them. For the exponential function, you can be able to do it without introducing the u. It is possible. But if you cannot be able to do it, just introduce the u. What is happening? This is what we had, y. Y was given by exponential 4x. This is what is happening. When I differentiate exponential, I still get exponential, the same function, but I come inside the power here. I come to the power that I'm circling. I differentiate 4x, I get 4. So the power that I differentiate, I multiply with it. In differentiation, we always multiply. That's where the 4 is coming from. Differentiate exponential 4x, you still get exponential 4x, but you come inside the power. Differentiate 4x, you get 4. You multiply by that. Let me go to the previous one that I had. For you again to be able to see. The previous one, this is what you are differentiating. Our y was given by this one. Let me change the color. Y. Our y was given by exponential 3x. So differentiate exponential 3x, you get exponential 3x, but you come inside the power here. When you differentiate 3x, you get 3. Then you multiply by that 3. So that is what happening. So you can be able to do it quickly without introducing the what? Without introducing the u. But you have to have done a lot of examples. Aya, try this one out. You can be able to try this one without introducing the power. Number 3. Because exponential is easy. Exponential x squared. Exponential x squared, you can be able to try that one out. Exponential x squared. Try, tell me what you get. See which answer is correct between those two. So let's do this one quickly. So u is the power. So u is given by x squared. So dy all over, sorry. So y will be given by exponential u. So dy all over dx will be given by still exponential u. Here du dx, when we differentiate x squared, what do you get? Du all over dx will get what? 2x. So I multiply those two. Multiply those two. What are you ending up? So dy all over dx will be given by 2x exponentially. But u was what? X squared. So I will get what here? 2x exponential x squared. So I think one of the person got it. So let me write back what I wanted to see what is happening here. So this one was our y was given by exponential x squared. So you can be able to see when you differentiate exponential x squared, the exponential x squared is still remaining, but you come inside the power. When you differentiate x squared, you get 2x, not 2, you get 2x. The power will come down, then you reduce the power by 1. You'll get what? You'll be able to get 2x, not 2. You'll be able to get 2x, not 2. So that's the function that we want to differentiate. So I'll just call you the power x squared plus 3x minus 1. So y will be given, the 2 is a constant, will remain, then exponential, the 2 will remain. The 2 will remain on the side of y. So basically the u is only the power, you just call the power. So here du all over dx will be given by, the power will come down, will get 2x plus 3. Differentiate a constant, you get 0. So here dy all over du. So 2 is a constant, is not playing any part. So when you differentiate exponentially, you still get exponential u. Remember the 2 is not playing any part. It's a constant. So I'll multiply these two. And I'll multiply those two to get dy dx. So dy dx will be given by, let me put brackets so you can be able to see. Because here I need brackets too. Exponentially. So the two can be able to multiply everything that is here. So the 2 can be able to multiply it there. So I'll get here what? 4x plus 6. You just open up the brackets exponentially. But our u was given by what? Our u was given by this. Our u was given by x squared plus 3x minus 1. So you can be able to see the power is still remaining. The power is still remaining what we had. So we want to give that dy dx. Dx will be given by 4x plus 6. And then exponential x squared plus 3x minus 1. So again, you can be able to see, let me give you the function that we had before. This is what we had. 2 exponential x squared plus 3x plus 1. When you differentiate exponential, this one will still remain the way it is. X squared plus 3x, sorry, minus 1, supposed to be minus 1. Then now you come and differentiate the power. When you differentiate the power, what are we getting? You differentiate the power, you are getting 2x plus 3. But that 2x plus 3 will have to multiply with a factor of 2. That's why we are getting 4x plus 6. That's why we are getting 4x plus 6, because there's a factor of 2 that we must be able to multiply with. There's a factor of 2 that we must be able to multiply with. So anyone with a question there? I want to move to another. So we have ln function. When you differentiate y is equals to ln x from the table, you'll get 1 over x. And I told you the table is available for you. You don't have to cram it. So I want to do an example. Y is equals to ln 5x. So you can be able to see that this one has is being multiplied by a constant of 5. So you cannot be able to say that it is what? It is the same as what we had. So we need to use again chain rule to be able to come and differentiate this one. So again, the function in brackets, I'll call it what? I'll call it u. The function in bracket. The function in bracket. So u will be given by 5x. And then here now I'll have y is equals to ln u. So here I'll have du all over dx, which I'll get it the same as what? 5. Here I'll get here dy all over du. What did I say about when you differentiate ln? Look what is happening to ln. So ln, when you have ln x, when you differentiate ln x, you get 1 over x. So I should expect that when I differentiate ln u, I should get what? 1 over u. 1 over u. Get 1 over u. You differentiate ln u, you'll get 1 over u. So again, I'll multiply these two. Multiply those two. When you multiply those two, what do you get? You get a dy all over dx will be given by 5 times 1 over u, be the same as 5 all over u. But u was given by what? 5x. But u was given by 5x, so I replace back. I'll be able to get that dy all over dx will be given by 5 all over 5x. I cancel that one, and I'll end up with 1 over x. And is the final answer. So you can be able to see my final answer is not what? My final answer is not 1 over 5x, but it is 1 over x. So I do another example. So remember, when you differentiate ln x, you get a 1 over x. Ln u, 1 over u. Number 2, you can try this one. Ln 3x. Can give me the final answer. Can try that one. Check this one out. So what is happening when you have y is equals to ln x? When you differentiate, you get dy over dx is equals to 1 over x. So what is happening? The answer that you are giving me, the final answer. So dy all over dx. So the ln, when you differentiate ln, it takes everything to the denominator. So I'll have 1 over 3x. But you remember to come and differentiate inside the power, the one that I'm circling in red, this one here. You come and do what? You differentiate inside now the bracket. When you differentiate 3x, you'll get number 3. That's why you're getting now the answer to be 1 over x. So that is another faster way. The ln will take everything down, but don't forget chain rule to come inside the what? To come inside the brackets, you differentiate 3x, you get number 3. Then you multiply the 2, you'll get 1 over x. And I believe this is what you have. This one is what you have as a due. This is what you have for your what? 1 over 3x was your what? 1 over 3x was your, this one was your d what? This is the dy all over, I think, du. And this one is the what? Is the du all over dx, if I'm not wrong. That's what you have. So you can be able to see it is still but a faster way of doing it. So I think that's okay. I'm okay with that. The final one, number 3. Y is equals to 3 ln x squared plus 2x minus 5. We do this one. But this one, for you to be able to see, I'll introduce you. You can be able to see. So our u is whatever that is in brackets. So u will be given by x squared plus 2x minus 5. And then our y will be given by 3 ln u. So here du all over dx. Then I'm getting as 2x plus 2. Here dy all over du. So the 3 is not playing any part in the what? It's not playing any part in the differentiation. It's a constant, so it will remain the way it is. When I differentiate ln u, I'll get what? 1 over u. I'll get the same as 3 over u. So the 3 is not playing any part, it will remain. Differentiate one ln u, you will get 1 over u. So my task is now to multiply these two and multiply those two. So I'll get here dy all over dx will be given by 2x plus 2, and then I multiply with 3 over u. Multiply this one, what am I getting? So the 3 will multiply every number that is in the bracket. So I'll end up with 6x plus 6 all over. But again, I go back, what is my u? My u was, let me go back, I can't remember. I go back. My u was x squared plus 2x minus 5. X squared, but u was x squared plus 2x. Was it plus 5 or minus 5? Let me see. Must be minus 5. It was minus 5. Minus 5. So I replace back that one. Minus 5. So here dy all over dx will be given by 6x plus 6 all over x squared plus 2x minus 5. The final answer. The final answer. So I'll go back to other functions now. Trigonometric. From the table, I'll only do 2. You'll go back to the notes, you'll be able to find others. The first one, when y is equals to sine x, when I differentiate, I get dy over dx. This one I should be able to get cos x. That is from the table. The other one is this one, the opposite now. What is y is equals to cos x? When I differentiate this one dy dx from the table, I should be able to get minus sine x. So I want just to concentrate on 2 examples on these 2, and then I'm done. So when you differentiate sine x, you get cos x. When you differentiate cos x, you get minus sine x. Don't need to cram, they are there in your table. So let me do this one. Example, let's differentiate this one. Y is equals to sine 2x. I'll not do it fast. I want to see if we are getting it. Try that one. Let's do this one. So whatever that is in brackets, I'll call it my u. Basically, is the function inside. So u will be given by 2x. So y will be given by sine u. So what is here du dx? The power will come down. That is 2 times 1 is still 2. Then we shall end up with x raised to power 0, which is the same as 1. So we shall end up with just 2. Here dy all over du. Let's go back and read it from the table here. The table is telling us when I differentiate sine x, I get cos x. It means when I differentiate sine u, I'll be able to get cos u. I'll be able to get cos u. So I multiply these two, I'll multiply those two. So dy all over dx will be given by 2 cos u. But u was given by 2x. Then the answer will be 2 cos 2x. So only one person got it. I go back, only one person got it. Yes, only one person got it. Price on it. Gichobi, Alex, and Terence, you forgot about the factor of 2. You forgot. Let check what is happening when you differentiate this one here. When you differentiate that one, sin 2x, you get cos 2x, no problem. But you come inside the power. You cannot not the power. You come inside the brackets now. Our function is 2x. So when you differentiate 2x, you get number 2. So you must be able to multiply with that number 2. You must be able to multiply with that number 2. Yes. So you must be able to multiply with that number 2, with a factor of 2. So a factor of 2 will still remain. Number 2. Number 2. Number 2. Y is equals to cos x squared minus 4. That one there, y is equals to cos x squared minus 4. So again, whatever that is in the brackets, I'll call it with my u. So my u will be x squared minus 4. And then y will be given by cos what? Cos u. So here du all over dx will be given by 2x. And then here dy all over du. When you differentiate cos u, when you differentiate cos what? When you differentiate cos x, you'll get negative sin x. That is from the table when you differentiate. So you're able to get negative sin u. I'm reading that one just from the table, so you don't have to cram it. So let me multiply these two. I just multiply those two. Multiply those two. Let me see what I'm getting. I'll end up with dy all over dx given by 2x. Then I multiply by minus sin u, which will be able to give me minus 2x sin u. Always the negative always begins. But x was what? No, not x, but u was what? But u was x squared minus 4. So the final answer that I should be getting should be dy all over dx will be given by negative 2x sine x squared minus 4. X squared minus 4. So this is what we have. So here u will be given by 3 minus 4x. Here du all over dx. Differentiate a constant to get 0, 3. To differentiate negative 4x will remain with negative 4. So y will be given by negative 2 sine of u. So dy all over du will be given by negative 2 cos u, because when you differentiate sine, you get cos. So I multiply those two. So what is negative 4 times negative 2? So negative 4 and then negative 2 cos u. We'll end up with 8 cos u. But our u was 3 minus 4x. But u is equals to 3 minus 4x. So I'll get here the final answer to be 8 cos 3 minus 4x. That is the final answer.